Hi guys, so my name is Mahek and today my presentation is on polymers. So the first thing is, what are polymers? So polymers can actually be described as compounds made up of long repeating chains. You can have two subsets. You can have synthetic polymers and natural polymers. Natural polymers have been in the world since life has begun. So these are your DNA, your starch, cellulose, lactic acid. Whereas your synthetic polymers have actually just been introduced in the early 20th century, and these include everything from cell phones to plastic water bottles. So it's a very wide array of products that are synthetic. So when you look at DNA versus cell phones versus plastic bags, you don't think that they're similar, but actually on a molecular and structural level, they are actually made of these long chains of polymers which are covalently linked together. So they're very similar. And so all polymers are actually made up of monomers, which are these single units which are linked together to form this chain-like structure called the polymer. So polymers are used interchangeably with the term plastic, but plastic actually refers to synthetic polymers or man-made polymers. And the reason why synthetic polymers were brought into the industry was to actually have more feasible, inexpensive, and more readily accessible polymers, more readily accessible substitutes for naturally occurring polymers, which were a lot harder to obtain and they were expensive as well. And so since these were man-made and they were synthetic, what they could do is they could engineer a bunch of different properties into the same material. For example, you could have rigid plastic that was still flexible, for example, plastic bags, or you could have rigid and dense plastic as well, for example, plastic bottles, which is also why a lot of the plastic that we use today can be used in automobiles as well, because it's lighter and it takes less fuel instead of using steel, which is a lot more dense. So the chemistry behind polymer formation is a process called addition polymerization. And given the example of ethylene, you have your free radical, which actually reacts with your ethylene molecule. So your radical will then attack the terminal carbon, breaking the double bond, and simultaneously the further carbon, carbon-2, will become a radical to give you this compound, where your R group, where the free radical makes a bond with the carbon, and then your second carbon becomes a free radical. And then that free radical will then react with another ethylene molecule, causing all your carbon chain to visibly increase in the number of carbons. And this polymerization reaction will keep on occurring until you actually run out of ethylene molecules, or until your two radicals combine together to form a neutral molecule which is unable to react. So there's been a lot of synthetic polymers that have been formed, but the big six are basically the ones that are available in the most abundant. They're the most abundant. So you have low density polyethylene, high density polyethylene, polyvinyl chloride, polystyrene, polypropylene, and polyethylene terephthalate. And basically, the thing with these, they're used to make a lot of really different things, everything from plastic bags to blankets to fabrics. And what's really interesting about it is that about 5 out of the 6 of them have very similar structures, such that only, as you can see, your functional groups are different. So basically, this just goes to show that all you have to do is change a functional group to have a whole set of different properties to make a brand new polymer. So there's definitely concerns with polymer use, even though they are very essential to our livelihood and our lifestyle. There's a bunch of different concerns. So most polymers are actually made with crude oil, but at the time when polymers were formed, this was a very sustainable commodity, but today it's diminishing and it's not as eco-friendly either. You can have non-biodegradable polymers, so they don't decompose in the environment and they accumulate a lot in landfills, and people aren't recycling any of these polymers either. So they're accumulating in landfills and they're infiltrating the ecosystems as well. So there's a lot of toxic chemicals in some plastics as well. And when I talk about toxic chemicals, one of them is bisphenol A, or for short BPA. It's an industrial chemical used to make plastics and epoxy resins since the 1960s. And it was used, and BPA is used in polyplastic carbons to basically to make your plastic water bottles or your clear food containers. And it basically gives the appearance, the rigid, clear appearance that are associated with your plastic water bottle. Whereas BPA in resins is actually used to line metal cans or aluminum beverage cans or aluminum cans. And the reason why they do this is so the food isn't in direct contact with the metal. But BPA is actually of a lot of concern to human health. It is an endocrine disruptor. And what an endocrine disruptor is that it mimics the effect of a natural hormone occurring in the human body, such that the effect of that hormone is either amplified, causing hormonal imbalance. So BPA in specific mimics the hormone estrogen. So the majority of the way that BPA actually gets into your body is orally. So you either ingest it. So when something is packaged with BPA, a part of that BPA actually gets into the food, which we then eat. But sometimes it can actually get in through the environment, so through dust in the air, or also through transdermal means as well. And just a quick overview of estrogen. So estrogen is a hormone that's found in both males and females, but in higher abundance in females. It is responsible for female puberty, as well as the differences seen in male and female bodies and regulation of the menstrual cycle. Whereas in males, it actually is responsible for increasing the effectiveness of male mating. And if there's an imbalance in estrogen levels in your body, you can have hormonal disorders, endocrine disorders, as well as a lot of diseases. So these are the diseases that you have an increased chance for. So it will be breast cancer, obesity, diabetes, reproductive disorders, prostate cancer, cardiovascular disease, precocious puberty, male and female infertility, and low sperm count in males as well. Especially for kids and infants, BPA is actually quite detrimental because their bodies are smaller and they're not really able to sustain that hormonal imbalance, and the level of BPA that it takes to cause that hormonal imbalance is a lot smaller than what it would be in an adult. So how BPA exactly mimics estrogen? So BPA is metabolized in the liver. So when it's metabolized, it's actually able to bind to your estrogen receptors. And when it binds to your estrogen receptors, that it mimics the effects of estrogen. And another way that it's actually able to bind is because if you look at it, they both have very similar phenolic structures, which allow them to be able to be, which allows BPA to be able to bind to the same receptors as estrogen. Testing BPA has been really difficult because it's hard to prove, because testing BPA directly on humans is very unethical. So the only way that they're able to measure BPA is for people who have already been exposed to BPA. And so an easier way to do it is through urine samples, because when BPA is in the liver, UGT is an enzyme that breaks it down to BPA glucuronide. And BPA glucuronide is actually found directly in urine, so when you take your urine sample, you can actually quantify the amount of BPA in that individual. So there's been a lot of BPA that's been produced worldwide, about 5.2 million metric tons, of which USA has produced the most, 22.9%. And in Canada, there have been a bunch of surveys. So recently, Health Canada, they conducted this survey where they tested 5,700 Canadians for toxic chemicals in their blood and their urine, and these were for people aged 3 to 76, and they found that 92.7% of the participants had BPA in them, and a few years earlier, when they had the same study, about 92.2% of participants had this BPA in their blood. So based on these new findings, there have been a lot of legislations against BPA. So in Canada, it is illegal to manufacture, import, advertise, or sell polycarbonate baby bottles that contain BPA. And Health Canada is actually trying to implement a minimum BPA level that products can have. But that's still really hard to do because, again, it's really hard to quantify the effect of BPA on humans. Canada has thus formally banned no other products to use BPA. But voluntary reductions have been undertaken, so now formula milk packaging has less BPA. Plastic bottles may have less BPA as well. And the second issue that was given to me was biodegradable polymers. And the reason why we would need biodegradable polymers is the fact that the rate at which we're producing plastics, it's a lot higher than the amount of plastic that we're actually recycling or disposing of in an eco-friendly manner. So even in 1950, we produced 2 million metric tons, and 2014 it has risen to 211 metric tons. And about 12% of all waste is plastic, and about 70% of that plastic is actually just discarded and it's not recycled. So they've come up with ways where you can discard plastics, and they thought that burning plastic to get energy was a really good idea, but in actuality it actually releases a lot of greenhouse gases, so it's really bad for you and the environment as well. And the problem that we have with plastics is that they're non-biodegradable. They're very durable, so they don't break down. They can only break down to smaller pieces, which disperse throughout the environment because fungi and bacteria don't have the enzymes to break them down. So they're very durable. And this is actually very ironic because the fact that plastics are durable is a property that makes them so enticing to industries, yet it's the property of plastics that makes them non-biodegradable and makes them stay in the environment for very long. So our solution is biodegradable polymers. Biodegradable polymers are designed to decompose when exposed to a bioactive environment. So they should be broken down by enzymes in fungi and bacteria, but also by non-enzymatic processes such as chemical hydrolysis, which is when you break chemical bonds by adding water to them. And biodegradable polymers are made from natural polymers, starch, cellulose, lactic acid. And these are degradable, and they basically turn these polymers into carbon dioxide, biomass, humic matter, water, methane, and other very natural products. So there's obviously certain products that are targeted directly by biodegradable polymers, and these would be your plastic bags, plastic containers, engineered fabrics, hygiene products such as baby diapers, consumer goods, which would be your cutlery, fast food cutlery, or egg cartons, and agricultural goods such as planters. And also, as you can see, they're also not very common. Like, why don't we hear about biodegradable polymers more often is because they're very expensive. A lot of consumers, as well as a lot of industries, they're unfamiliar to this concept. As well, you need a lot of infrastructure to be able to to ensure the correct disposal of these biodegradable polymers to a bioactive environment. There have been a bunch of biodegradable polymers that have been produced, such as starch-based biodegradable polymers. These are used to make sheets, films, and styrofoam, and they're really renewable, they're inexpensive, and you can just get them straight from corn. And they're water sensitive, so when they undergo chemical hydrolysis, which is what we want. And you can have cellulose-based biodegradable polymers, which actually account for the rigidity that is provided by plastics. And a lot of studies said that cellulose is not biodegradable, but a strain of cellulose acetates, are actually biodegradable to a certain extent. And then you have biodegradable polyesters, which are manufactured from lactic acid. So these actually also will disintegrate in soil, and these are used to make a lot of fabrics today. And then you have your water-soluble biodegradable polymers, and these are really important because a lot of the plastics that we use in our environment are ending up in your lakes and rivers and oceans. So these are really important because they will just disintegrate in water, and these are used as detergents, thickeners, and cleaning products. Biodegradable polymers are really important because, as you can see, they actually follow a very cyclical pathway. So you're not actually changing the biological imbalance or the chemical balance of the soil or the environment, because as soon as you have composting, you form your carbon dioxide, water, biomass, which is used in conjunction with water and sunlight to actually fuel this plant to make other natural polymers. And when you make these natural polymers is what we need to make biodegradable plastics. So there's a lot of benefits of biodegradable polymers. You're reducing plastics derived from crude oil and fossil fuels, decreased plastic accumulation in landfills, and even though there's not a lot of them here and they're not very accessible right now, they will be, and it's the future of a green chemistry and green environment. And even today, you can see there's changes happening. For example, if you go to your nearest Walmart, they charge you 5 cents for a plastic bag, so you're more inclined to bring a reusable bag. Also, the fact that a lot of grocery stores now will also have like plastic bag recycling, which is also a way for you to definitely lower the amount of plastics that we're using and be able to recycle them properly. But that being said, I think polymers have really taken the world by storm, and they are a very important part of our lifestyle, but we have to have certain regulations and legislations to be able to preserve the environment and our health as well. Thank you.